So just like the previous day, we're gonna keep adding things to this and properties. So we're still going to be proving or verifying that our identities are equal to each other or are the same. So this is part 2. So in this section, again, we're gonna be using the reciprocal identities. We're gonna be using the quotient identities and the Pythagorean identities. So those are the main 3 identities we're going to be using for the next couple of parts. Okay, so we're going to be adding or subtracting. Just like regular equations, you need to get a common denominator. So you know, or I'm hoping that you know, that to get a common denominator for this, you want the denominator to be sine of x, cosine of x. That means I need to multiply this left equation, top and bottom, by cosine x. And I need to multiply the cosine one by top and bottom by sine of x. That's the only way I'm going to get that sine x, cosine x on the bottom. So that means I'm going to have 1 times that is going to be cosine x. And then we know that cosine times sine is just going to give you this. And then we're going to have this one times that one is going to be plus sine of x. And this times that is just going to give you the bottom part. And now that's already simplified because nothing can cancel out. We cannot cancel out these signs or these cosines because of that plus sign. Together, it's an answer. If this was a multiplication symbol, then yes, you could cancel things out. In addition or subtraction, you cannot cancel anything in the numerator, denominator, only if you factor it out. So that means that is your answer. This is simplified form. We're not verifying anything yet. We're just kind of simplifying so we get a gist of how to manipulate things. So again, if we want to get a common denominator, we have to multiply top and bottom of each one of what we want. We know we want the common denominator be a combination of those denominators. So we know that we're going to probably have something that looks like cosine of x, sine of x minus 1. So it's a lot like the previous one, but this one has a minus 1. So that means on this side, on the 1 over cosine of x, we're going to multiply top and bottom by sine of x minus 1, both denominator and numerator. And for the left side, which is the 1 over sine of x minus 1, we're going to multiply by cosine of x. That means when we multiply this times that, I'm going to have sine of x minus 1 plus cosine times that is cosine of x. Okay, and then all you have to do is basically write it in standard form. So if we write this in standard form, we're going to have sine of x plus cosine of x minus 1 all over cosine of x, sine of x minus 1. And again, I want to point out that you cannot cancel this cosine of x with that one because of that plus sign. All of this is all stuck together. The only way I could do that if I would factor out a cosine from every single piece, and then I could cancel it out. So that means this is my simplified form. We're not verifying yet, but we are going to move on to that in the next couple slides, I think. This is the last one that we're going to work on how to get a common denominator. That way, after this one, we're going to be proving or verifying after this one. So again, think of it like if you have a 1 under it and you need a common denominator. So we need our common denominator to be cosine of x. That means this time I'm only multiplying my right side. I don't know my left and my right anymore. So I'm going to have 1 plus this times that cosine of x. And this would be my simplified form. I'm not proving anything yet. I'm just simplifying. Okay, now we're getting to the part where we're going to be using our fundamental trig identities to transform one side of the equation to the other. So if you look at it right here, we have cotangent of x plus secant of x equals this. These two in equations are equivalent, but they want you to prove, aka verify, that the left side equals the right side or that the right side equals the left side. It really doesn't matter where you start. I personally like to start on the side that looks less complicated and change it to something that looks more complicated. But sometimes it doesn't work out like that, and I start on the left side, and then I can't see it, then I just start the right side. So there's no wrong way to verify. You can verify any way. But if we look at this and we look at our trig identities that we have from before, we know that we could rewrite a lot of this stuff as sine and cosine. So my suggestion is to write everything as in sine and cosine, then that'll make it easier. We know that cotangent is the same thing as cosine of x over sine of x. If you look at your cheat sheet where it has all your trig functions, we know that secant of x is the same thing as 1 over cosine of x. And if you look at that, we're getting closer to what we want. We want a sine x and cosine x. So now we need a common denominator. So that's the next thing we do. This is what we practiced the previous one. So I'm going to multiply this side by cosine of x top and bottom. And this side a sine of x top and bottom. And now I'm going to have cosine of x squared, because there's two of them, and that square should be there, over cosine of x sine of x plus 1 times sine of x is sine of x. And we basically have the same thing. These are interchangeable. That's fine. If you have cosine or sine, those are fine. So this is literally what I just did. So I just verified it. It works. Again, I kind of like working on the left side, so I'm going to work with this side, tangent theta, cotangent theta, and I'm going to change the tangent theta and the cotangent to sines and cosines. So I know that tangent is the same thing as sine theta over cosine theta from my trig identities. I know that cotangent is the same thing as cosine theta over sine theta. And now that I have that, my next thing is I'm going to try to kind of manipulate it to get cosecant and secant by getting common denominator and see what happens. So the next step that I'm going to do is get a common denominator. So I'm going to multiply both sides by, this side needs a sine theta. So I'm going to put a sign in the middle. Basically, I'm going to multiply top and bottom, being lazy and not writing the sign on top and the sign on the bottom. And I'm going to do the same thing on this side. It needs a cosine. And I'm put it in the middle because this is my shorthand way of saying I'm going to multiply top and bottom by that. So that means I'm going to have sine theta cosine theta on the denominator, and sine theta times sine theta is sine squared theta, plus cosine squared plus sine squared is cosine squared theta. And we know that sine squared plus cosine squared is 1. So now we have 1 over sine theta cosine theta. And if we separate that, we have then sine theta times 1 over cosine theta. And we know that 1 over sine theta is cosecant theta. And we know that 1 over cosine is secant theta. So we have checked and we have verified and proven that the left side is equal to the right side by using our trig identities that we know. This is the last one on this section. So again, I'm going to start by, I like to work with the left side, so I'm going to work on that side. And just like before, I'm going to change that cotangent into sine and cosine. So I'm going to write cosine of x over sine of x, because that's cotangent, plus sine of x. And we could write that as a 1 under it, and then we need to get a common denominator. So this side needs a sine of x on top and bottom. So I'm multiplying that at the top and the bottom. And now I'm going to have sine of x on the bottom. And on the top, I'm going to have cosine of x plus sine squared x. And literally that's what I have for the left side. So it works out and it checks out.